So the idea here is to make one more video where we find values of trigonometric functions using a unit circle. So I've got a picture of a unit circle here. One difference is, so let's just look specifically at the first example here. We're asked to find tangent of 14 pi over 3. Well, you'll notice 14 pi over 3 doesn't show up anywhere on this unit circle. And that's because 14 pi over 3 is bigger than 2 pi. So the unit circle is displaying these common angles that we like to refer to between 0 and 2 pi radians. So if an angle is, say, less than 0, so negative, which is going to be an issue for B and C here, or greater than 2 pi radians, or 360 degrees, which is going to be the issue with A and D, then we need to find a coterminal angle that is between 0 and 2 pi. So if the angle is too big, like this one, then what we should do is subtract 2 pi. Remember that to find a coterminal angle, we either add or subtract a full rotation, which is either 2 pi if we're working in radians, or 360 degrees if we're working in degrees. So in this case, we're working in radians. The angle is too big, so I'm going to subtract 2 pi radians. Now, in order to do this subtraction, we need a common denominator. So I'm going to think of this 2 pi as being 2 pi over 1. Then I'm seeing if I can change colors. It's a little tricky here. No, I can't. All right. So to get a common denominator, I'm going to multiply the numerator and denominator times 3. 14 pi over 3 minus 2 pi is the same as 14 pi over 3 minus 6 pi over 3, because this is equivalent to 2 pi. And since they're both, oops, I missed the pi here. Since they're both over 3, then we can combine 14 pi minus 6 pi. And now it's just like you're combining like terms. Just subtract 14 minus 6, so that's 8 pi over 3. Now the sad thing there is that that's still bigger than 2 pi. This is still not an angle that shows up on the unit circle. So we can find a coterminal angle to that. We can subtract 2 pi as many times as we want, because every time you subtract 2 pi, it's like you're making a full lap around the circle, but you're going to wind up where you started. So if we make another full lap around, another full rotation, we're still going to wind up where we started. So 14 pi over 3 minus 2 pi. Well, again, we need a common denominator, so I do times 3 on the top and bottom. So that's the same as 18 pi over 3 minus 6 pi over 3. I'm going to go ahead and put it all over 3. So 8 minus 6 is 2. So 2 pi over 3. So 2 pi over 3, this position here is the same as 14 pi over 3. The difference is that with 14 pi over 3, we make 2 full laps around. That would be 6 pi over 3, and then another lap would be 12 pi over 3, and then an extra 2 pi over 3 to get here. So the terminal point on the the point along the terminal side of this 14 pi over 3 angle that lies on the unit circle is this one, negative 1/2 square root of 3. Now we've got to use those coordinates to find the value of tangent. So tangent is y over x, if you look at that unit circle definition of the tangent function. So that's the y coordinate, which is positive square root of 3 over 2, over the x coordinate, which is negative 1/2. When they're both over 2 like this, the 2's are going to cancel. And if you want to see details for that, the way that works is we could multiply top and bottom times 2. So then the 2's cancel here, the 2's cancel here, and you end up with square root of 3 over negative 1, which is negative square root of 3. And so our final answer for part A here is negative square root of 3. So it just took some work to find a coterminal angle that actually shows up on the unit circle, and then you just refer to these xy coordinates. All right, so I want to do the same thing for this cosecant of negative 315. I'm going to erase. All right, so now we want, oops, thought I was in drawing mode. Now we want to find cosecant of negative 315 degrees. So with a negative angle that doesn't show up on the circle here, so what we need to do instead is find a coterminal angle. And I mentioned earlier that if it were working in degrees, then we want to either add or subtract 360 degrees to find a coterminal angle. So in this case, because it's negative, we want to add 360 degrees, and that gives us 45 degrees. So that means that we have the same terminal side. Let me try to get rid of this here. Let's see if this works. Can I draw? No. So, oh, and I just realized I only have radians on here. Okay, well, so if you guys are looking at a unit circle that also shows degrees, 45 degrees is going to show up in this same position as the pi over 4 radians. 45 degrees is the same as pi over 4 radians. So the fact that this is negative 315 degrees just means we went around that way, but the important thing is that it has the same terminal side, and so the point where the terminal side intersects the unit circle is going to be the same. Now, cosecant is the reciprocal of the sine function. The way I remember those is one starts with S, one starts with C. In each of those, like secant and cosecant, and then cosine and secant, those reciprocal pairs have one starts with S, one starts with C. Anyway, so the value of sine is given by the y coordinate on the unit circle. So that's going to be 1 over the y coordinate here, which is square root of 2 over 2. Oops, and I don't know why I just stuck in a negative. Sorry, guys. It's going to be 1 over y, which is square root of 2 over 2. And so you could just flip it, 2 over the square root of 2. That does simplify to the square root of 2. Either answer here is fine with me. I believe Alex will accept either answer. If you're wondering, well, why do you say that? Why is it equal to the square root of 2? It's a matter of rationalizing the denominator. So you have the square root of 2 on the bottom. If you multiply top and bottom by square root of 2, then you get 2 times the square root of 2 over square root of 2 times itself will be 2, and then the 2's cancel. So that's where that square root of 2 comes from. And so now we have that for the value of cosecant of negative 315 degrees. Okay, so continuing over to this cotangent of negative 5 pi over 4. Cotangent of negative 5 pi over 4. So here again we have a negative angle. We'd like to find a coterminal angle. We either add or subtract 2 pi since it's in radians. Because it's negative, I know I need to add 2 pi to turn this positive. Right now that's over 1, so we need a common denominator. I'm going to do top and bottom times 4, so these denominators match. Then they would both be over 4, and we can combine the numerators. So negative 5 pi plus this is 8 pi. So negative 5 pi plus 8 pi. Now we just combine negative 5 plus 8 is positive 3 pi over 4. So the negative 5 pi over 4 angle is coterminal with this 3 pi over 4. Another valid way of thinking about this is you just start at 0, we revolve in the negative direction. You may think of this negative 5 pi over 4 right here as a whole pi, which would be 4 pi over 4. So negative pi takes you from here to here, and then you've got another negative pi over 4. So another pi fourths in the negative direction would be right here, and so you would land in this 3 pi over 4 position. That's just another way to reason it rather than just always doing coterminal angles, if you would like. Okay, so now we want the value of cotangent, which if you look at your unit circle definitions of the trig functions, cotangent is x over y. So the x coordinate is negative square root of 2 over 2. The y coordinate is positive square root of 2 over 2. So since we have the same value or at least the same magnitude top and bottom, the square root of 2 over 2's can cancel, and this will leave you with negative 1 over 1, so negative 1. The value of cotangent of negative 5 pi over 4 is negative 1. If you like another way of dealing with that, if you don't like the way I just crossed them out, you could bring this fraction out of the denominator and flip it over. So 2 over the square root of 2. And then the 2's cancel, the square root of 2's cancel, and you're just left with negative. If everything cancels like this, we would just put a 1 placeholder here. So that's another way of coming up with that negative 1. Okay, and then the last one, secant of 990 degrees. That's bigger than 360 degrees, right, which is one full rotation. And so if you take 990, you subtract one full rotation, 360 degrees. That's going to give you, well, yeah, okay, 630 degrees, which is still bigger than 2 pi or 360 degrees. So we need to subtract 360 degrees again. If we do that, what do we get? 40 plus 30, this is 70, and then 270. Okay, so that means 990 degrees. We subtracted 360 twice. That means, here, another way of thinking about this, secant of 990 degrees. This is 360 plus 360, that'd be 720, plus another 270. So 990 degrees is we go all the way around once, that's 360. Go all the way around again, that's 720. And then go another 270 degrees. So that takes you to this terminal side, where you see 270 if you're looking at the unit circle PDF that I posted for you guys. So if we choose a point on the terminal side, ideally where it intersects the unit circle, this is 0, negative 1. Now secant is the reciprocal of cosine. And cosine is given by the x-coordinate. So the x-coordinate here is 0. That's going to give us 1 over 0. Anytime you find yourself dividing by 0, so when you're evaluating tangent or cotangent or secant or cosecant, you can potentially get a 0 denominator here, which means that this expression is undefined. So secant of 990 degrees, it turns out, is undefined.